Welcome back. We are going to look at a problem which is going to be, let's say, if a transfer function g of s is given to you and the transfer function is 100 over s squared plus 15s plus 100. Okay, so this is a typical problem that will help you to solve the problem number 2 on your homework, and also I think problem 3 also you can solve this, but it's mostly problem 2. So first of all, we are going to find the natural frequency omega n, so that should not be that hard, remember. So if you want to write this in the format of the general form, you know this is equal to omega n squared divided by s squared plus 2 times zeta omega n times s plus the omega n squared. So this is the general format, isn't it? So if you can check this out from here, that omega n squared is really equal to 100, isn't it? So 100. So we can take a square root of that. So omega n, the natural frequency, will be 10 radians per second. So that should be clear for you. And then if you compare this 2 times zeta omega n, 2 times zeta omega n, if you compare with this equation, is 15, isn't it? So now we can find the damping ratio. Remember, zeta is the damping ratio. So zeta will be equal to 15 divided by 2 times omega n. That will be 2 times 10. And if you do this, 15 divided by 2 is 7.5 divided by 10 will give you a damping of 0.75. So if you see that 0.75 is less than 1 but greater than 0, so it's going to be, the system is going to be the underdamped, right? And you can kind of see that even with the graph. It goes, well, this is not the graph for the system, this is the general format, but 0.75, it is going to be an underdamped, right? So let me write this here. This system is going to be underdamped. Okay. So two things are out of the way, but we still need to compute some other stuff. The question is asking you first to compute, I guess, the T of P, which is the peak time. Now, if you look at this graph, let me use a different color here. If we are going to use this graph, you can see this is the TP, is peak time. It gets to be right here at this point where it goes peak, where the waveform goes to its peak, is called the peak time. Okay, so how do we express the peak time? The peak time is given by pi over the omega n times 1 minus the damping ratio square. Well, if we plug all this information in that we got, so that would be equal to 10, 1 minus 0.75 whole square. Well, you don't have to do this. You have to put it in either in your calculator or put in the MATLAB. It's going to come out, the peak time will be somewhere around 0.475 seconds. And you can see in the graph, how long does it take to get to the peak value? That is the peak time. So we're done with the peak time, we're done with the damping ratio, we are done with the natural frequency. So let's take a look at the settling time. Settling time is somewhere when it reaches to the 98% of the final value. Okay, so within 2%, so that's 98%. So this right here is called what? It's called the peak time. Peak time. Okay, and let me use this green color for the, whatever this color is, I don't know. We'll find out. Blue color or green color. Okay, so this is the settling time. Settling time. So settling time, as you recall from our previous discussion, is when the signal gets to the 98% of the final value. And here's that final value. You can see that final value on the graph. When it gets to be the 98% of it, that's the settling time. Well, the question arises, how do we compute that settling time? Well, the settling time, as we did before for the first order system, here for the second order system is equal to 4 divided by zeta times omega n. Well, we do know zeta, so that's 4. That's the good news. 0.75 times the 10. Well, if you put that into your calculator, you are going to get a settling time of 0.533 seconds. All right, so far so good. We got everything in the problem solved now. We got the damping ratio, we got the natural frequency, we got the settling time, we got the peak time. But what about the rise time? Rise time can be really difficult to find if you are going to use the formulas. Instead of using the formula, we are going to use this graph. So please make sure you have this graph. Even if you don't have the reference book, take a snapshot of this graph while you're solving the homework problem. This is really going to help you a lot. So much for that. Let's take a look at how do we find the rise time. It is going to be very interesting. So we know our damping ratio that we just computed is somewhere around here. Oops, it's not going to let me write on this. Oh, well, it does. So that'll be 0.75, right? So if I extend this guy, it's not going to be such a good straight line, but close enough. Hey, we even have numbers in there, so getting close enough, right? So 0.75 is going to give you close rise time times the natural frequency. Let me write this right here on the graph. So TR times the natural frequency is, as you can see from the graph, is 2.3. Now it is a piece of cake to find the rise time. If you try to do it mathematically, it's going to be a cumbersome formula. So in order to avoid that, we will be using our graph, and that's how it's supposed to be anyway. So the rise time, TR, is going to be 2.3 divided by the natural frequency omega n, and you do have the natural frequency, so 2.3 divided by 10 is going to give you let me write this down clearly. So it is, let me erase this, okay. So the rise time that you are going to get, 2.3 divided by 10, is going to give you 0.23 seconds. Okay, so the bottom line here is you must have this graph. The bottom line is if you're given a transfer function, especially a second order system, these are the techniques, the formulas that you're going to use, where you know the natural frequency just compared with the original function. You get omega n is equal to 10. Once you get omega n, then match it with whatever the number is in here. Find the damping ratio. Once you got those two guys, then it's just a matter of plug and chug. Plug it into the formula, get the peak time, get the settling time, and then get your, what we call is the rise time by using this graph over here. Okay, so we are done. We are making some good progress here. So hopefully I'll see you in the next video shortly, where we can look at some other problems that you can solve on your homework. So far you are good to solve problem 1, problem 2, and problem 3. And hopefully I will talk about the problem 4 and problem 5 tonight. Thank you.